This is part 3 in series of tutorials about how to make this parametric facade. In this tutorial we will look at how to make this 4-point adaptive panel. This is one of the most complicated families I have ever made, so this is step-by-step video of how to make this family. I have written timestamps in the description of this video, so you can skip to the next part or to the previous part, and you can also fast forward or slow down the video by pressing Shift plus greater than or less than sign on a video, or in the options of the YouTube mobile video. And don't get discouraged about the length of this tutorial. There is much repetitive process, but you will learn much about how to make truly adaptive families, about reference lines, reference points, math in the family parameters, and overall logic behind a complex adaptive family. So grab a coffee and let's start with the overview of what we are going to do. So this is 2D line representation of the family that we are going to build. This is the top side of the model, and the halftone lines in the middle represents the back side of the model. In the beginning we are going to focus only on the top side of the model, because the back side have the same logic as the top. So this next drawing represents surfaces that are going to be used, and 4 adaptive points that are going to control our family. So we will divide our top with 1, 2, 3, 4, 5, 6, 7, and 8 main surfaces. And we need reference lines to make those surfaces. And the most difficult one is this reference line that represents a fillet arc in the corner of this family. So this arc needs to be tangent to those offset lines in the middle. And we need to calculate the length of this arc's radius. To understand how the arc is created, let's draw it with a simple line. Select Arc tool, select the beginning, the end, and the middle point for the arc. And this is the point that we need to calculate. And this calculation is exactly why this family is so complicated, because without this middle point, this fillet wouldn't be perfect tangent to the line on the left side and on the other line in the other side. So if you have a wrong dimension for this middle point for this arc, it just wouldn't be correct. And it wouldn't be perfect tangent to those 2 lines, and the fillet just wouldn't look good or correct. So to recap, we have a arc with the beginning point, the end point, and the middle point. And this is the corner of these 2 lines. And also we know the position of the beginning of the arc and the end of the arc. We call them the fillet length, and we can use that number to calculate the radius needed for the arc to be tangent to those 2 lines. This length from the middle of the arc and to the corner is not necessary. We cannot use this number to calculate the radius for the arc. So as you see, this arc that I drew is not the perfect fillet arc for this corner, and we need to use math in our parameters to calculate it. The good news is I'm bad at math, so if I could do it, you can do it too. So let's overview the whole math. I have separated it in 4 math equations that we need to use in our parameters to calculate that arc. In the beginning we have a rhomboid with 1, 2, 3, 4 corners. These are adaptive points that control the whole model. So next we have basic parameters that we are going to read from this rhomboid. L12, L23, L34, and L14, and 2 diagonals, L24D and L13D. So how do we use them? Let's close this project browser to have a better look at this formula. And here you can see the math expression used to calculate this angle for the first triangle. We will separate the rhomboid in 4 different triangles. So for each triangle we have the same formula. The first parameter is going to be called 1ang, so it's representation of angle for the first adaptive point. Here you can see that I added to this formula these parameters that we are reading from this triangle. Diagonal L2 for D, for 2. Here we have again L12, L14 added to this formula. And down below, here you can see the representation of the expression for the Revit parameter that we are going to use later. And down below you can see the expression filled with the numbers from this 2D representation. So when you draw your own, you can fill this with your own numbers to check that the expression is working. So next we are going to calculate a length between the start and the end point of the arc. I call this parameter 1 len, and here are the math expression that uses our fillet distances that we will input later. Basically, this is a triangle with two known sides and one unknown side. And we also know the angle between two known sides. The angle 1 that we calculated in the previous step here. This is the same angle, just offset in the inside of the triangle. And we can use that to calculate 1 len. The angle is the same as here, as in the top of the triangle. Here you can see the expression for the Revit parameter. You can copy that from the description of this video. Here you can see the same expression filled with values. And with my calculation, the distance between the start and end point is 115. And next we need to calculate a radius for the circle that is tangent to these two lines. The left one and the right one. And how do we calculate this radius? We use already known values like 1 angle, 1 len that we already calculated. We look at this problem as with previous one. We have triangle with two known angles and one known side. This is called right triangle. We know that half of the 1 length is this side of the triangle, and we know two angles. One is the half of the one angle and one is 90 degrees. This is the expression that is added to Revit parameter. You can copy that from the description of this video. This is the expression filled with values, and I get the outcome of 70.336, and this is the radius for this circle. And next, let's look at the last equation. Let's go down a bit to the next scheme. Let's zoom in a little bit. And now this is the radius that we calculated now for this circle. And next we need to calculate this small line, and we are going to call it 1e. And this is the distance needed. This is the middle point of the arc, and to calculate that we will use this radius that we calculated previously. We will calculate this side of the triangle, and we will subtract it from the radius that is the same here as here. And we will calculate this small side of the triangle and subtract it from the radius. And in that way we will calculate the length of the 1e. So here is the expression. Use it to calculate that small side of the triangle. And here you can see that I'm subtracting it from 1r, the radius. And this is the expression used to calculate that small side of the triangle. This is the expression filled with values, and the outcome that I get is 29.87. And later, if we draw an arc, we can see that the radius of the arc is 70.336, and it is the same as we calculated previously. So our calculations are correct. And here you can see that if I draw a dimension line from this line to the middle of the arc, we get the value 29.87. That is the same as in the previous calculation. So we can double check that everything works. And we have perfect arc between these two lines. And that is all for the math side for this family. it kind of feels much, but if you look at it and zoom out, it's just 4 expressions, one after another. And it's very important to understand the logic behind this family, so you can later modify the family or catch out any bugs that you have. So if you're still with me, let's start to model this crazy family at last. Let's create new family, new generic model adaptive family. Let's open the family template, and okay, here's the empty family. The first thing we need to do is create 4 points representing our rhomboid. 1, 2, 3, 4. Now let's select those points and click make adaptive. Now we have 4 adaptive points, and it's important that those points are in the order. Now select reference line, enable 3D snapping, and then click through points 1, 2, 3, 4, and back to 1. And now you can check that the reference lines are connected to those points. Select the point and you can move it in any direction, and the reference lines are following the point. Okay, now let's rotate the view, and now we'll start by adding parameters. Okay, 1, 2. Now let's change the scale. And I can see that the reference points are too far from each other, and in my experience it's good practice to model the family close to the size that is going to be used in. The panel will be a few meters wide, so we need to move those adaptive points closer together, so it's easier for us to understand the dimensions, and when we load the model into the final Revit project, the dimensions that are coming with the family are not interfering with the size of the family, and there are no errors. Let's move them a little bit more closer together. And in that way we can also test that the reference lines are connected to those points. Let's move this point up and everything works. Okay. Now the first parameter is going to be L12. It's going to be instance and reporting parameter. Okay, now onto the next parameter. Let's add dimensions. Select the dimension, press label, new L23 instance and reporting parameter. Okay, so now the next one. Select align dimension, select point 3 and 4, create dimension, and select new parameter. This is going to be L3, 4 instance and reporting parameter. Okay, now the last one is going to be 4, 1. Let's select that, create new. The name is going to be L14. It's going to be instance and reporting parameter. Okay, now we need the diagonals. Let's select 4 and 2. Let's pull this out, select, press new, and let's rename this L442D from diagonal. Okay, now the other diagonal is going to be 1 and 3. Let's select that, new, and it's going to be named L13D, and also it's going to be instance and reporting parameter. Okay, now what do we do next? Next we need to save the model. That's always important. Let's save the model. I already have the name. It's adaptive 4 points, and I will rename this 4 points version 3. Hit save. And now let's look at what we have. We have the first step. We have made the rhomboid with these 4 parameters and 2 diagonals. It looks like this diagonal have a wrong name. It's not 4.2 but 2.4D. That's a mistake we have to fix now. It's quite easy. And yeah, we have to rename this parameter. It's not 4.2 but 2.4. Click edit. It's instance and reporting, and let's rename this to 2.4D. Okay. So now it's always important to check that the model is working as expected. We can move the adaptive points and the parameters are connected to those points and moving along. It's a good practice to check the model periodically. When you model something, then you check that the thing you made is actually working before starting a new thing. Because otherwise, if there is an error in the end, you have to check all the components to know where the error is coming from. If there's many things dependent on one another, then it's going to be hard to find the error. Now it looks like everything is working great in this stage of the design. Next we will add offset lines. Select point, select draw on face, and pick some random place on the line. Now add normalized curve parameter 0.5, so it's always in the middle of the reference line. Now add 3 more points to the next reference lines. Select those points and also add 0.5 to normalized curve parameter, so they are always in the middle of the reference line. Now we need to add offset points to those points. Select point and select set work plane. Pick the work plane you want to draw the point in. In our case, we need to select work plane vertical and parallel to the line. Select that and add a point. Now select the point you added and you can specify the offset, but we will add offset parameter to this property so we can specify it later. Select new, let's call it offset, and let's group it under the graphics. Hit OK. And now let's add a value to this parameter. Let's say 50. And as you can see, it moves the point but in the wrong direction, so we need to rotate the placement work plane. Let's say 180 degrees, and now the point is in the right direction. And let's test again. Let's add 100, and now it moves in the direction that we need. Now we need to add 3 more points to the reference lines. In L23, select point, select work plane, add point, select the point, and add offset. We already have offset parameter, and again it moves the point in the wrong direction, so select the placement work plane, add 180 degrees rotation, and move to the next point. Again, select the placement work plane, add point, select point, and add offset parameter. Now this one moves in the right direction, so no need for rotation of the placement plane. Now move on to the next point, select work plane, add point, hit OK. Now select the point and add offset parameter. Select offset parameter, OK, and this also moves in the right direction. Okay, now we have 4 offset points. Now let's add 2 more to each one of them. Select vertical perpendicular work plane, add point, OK. Now select that point and add again offset value, let's say 500. Okay, now let's add a parameter to this property also. Let's call this L12 offset extension. Okay, add this as instance parameter. Okay. Now I realize that the offset parameter is not instance, so we need to change that. Edit offset parameter, add it as instance parameter. Okay, now we need the point that we just added to be always on the outside of our rhomboid. So how do we do that? Let's divide the length of L12 in half and add, let's say 100. So this point will always be on the outside of the rhomboid. Hit OK, and now as you see, the point is on the outside of the rhomboid and will always be there. Now let's add another point. Set work plane, add point. Okay, select the point. And now we need to move this point on the other direction. Let's add another parameter. Let's say, well, 1, 2, offset extension negative, because we need a negative value for this point. Okay, so let's set this one also as instance parameter. Okay. And now we need the same value, just negative. So we can copy the name of the L12 offset extension and we can multiply it by -1. So it will always be negative, but the same. And now the point is on the other side of the rhomboid and also on the outside of the rhomboid. And now we can add a reference line between these 2 points. And this will be the offset line. Select reference line and connect these 2 points. Now we can test this creation. Let's select the adaptive point, and if you move it to the side, you can see that the offset line is moving with it, and it's always parallel to the line L12, and that's what we need. So let's move those points back to the base work plane and do the same thing with the 3 points that are left. So basically you can fast forward this part because I'm doing just the same exact things as I did with the first offset line. Make 1 point on the one side of the offset middle point, then make another point and offset it to the other side of the middle point. For now I'm not adding any parameters, I'm just adding those points, and then later I will add all the parameters to those points all together. And this way I think it's a bit faster to add those points by just concentrating on one task and then concentrating on the other task. Like just add points and then add parameters to those points. Now the last offset line, select point, set work plane, choose vertical, add point, move the point to the side. Again, select point, select work plane, add another point, select added point, and move it to the other side. Now when all points are added, open parameters panel, and we have to start to create new parameters. Let's start with L23. Name the parameter, offset extension, its instance parameter. Okay, now exactly like before, we need to divide the length of L23 and divide it by 2 and add 100. So the point is always on the outside. Now copy the name of the L2 offset extension parameter, create new, paste the name and add negative. This will be the parameter for the other point. Now this will be just the negative of the previous value. Okay, now we need parameters for other 2 lines. Line L2 offset will be line L34 offset, its instance. Okay. Now let's add the name L34 divided by 2 and add 100 millimeters. So it's always on the outside. Let's copy the name, create new parameter, paste the name and add negative to the end. It's also instance parameter and is just the same as previous but negative value. And now we need the last two parameters. Okay, create new. And this will be L14 offset extension, also an instance parameter, and it will be the half of L14 and add 100 millimeters at the end. Okay, create new and paste the name and add negative on the end. Okay, and this will be just as previously, the negative of the previous parameter. Okay, now all the parameters are made. Now we have to apply them to the points. Save the model as always. Start with one side. If it's negative, you have to add a negative parameter. If it's positive, you have to add a positive parameter. Let's move on to the next point. It's negative, so we need to add negative value. The next one is going to be positive, so we'll add a positive offset parameter. And the last two, this is negative, so we need to add a negative L14 offset parameter. And the last point is going to be a positive L14 offset extension. Where is it? Okay, here it is. Add that to the point. And now you have all parameters added, and now we need to connect the points with reference lines. Connect points, it doesn't matter in what order you do it. Now connect next to. We can uncheck the chain so it doesn't chain the reference lines. Now add the last one. Now when all offset lines are added, as previously, it's very important to check that everything works as expected. Now we move those points around and we can see that the offset lines are following the rhomboid's outer borders, and everything seems to be working as expected. Now let's move those points back to the base work plane. Let's check that one. Yeah, that also works. Now let's move all the points to the base work plane. You can align them one by one, just as I am trying to do. Now remember to save your model, because if something breaks, you can always go back to the saved model. Okay, so far everything looks very good, and the next step is to add a fillet lines, a fillet parameter that I talked about previously. That is the start and the end point of the fillet arc. So how do we do that? Take a point and add it to the reference line. Select the point and click Host Point by Intersection and select Other Reference Line. Now the point will always be in the intersection between these two reference lines, and that is very, very useful. Now if we zoom in, we can see that the point is exactly where these two reference lines intersect. Now we need to add another point on the other reference line. Select that point and again click host point by intersection and select the first reference line. Now we have 2 points on both of the reference lines, hosted by intersection between these 2 reference lines. Now we need to add 2 more reference points. Select point, set work plane to the first point, add the point, select the point, and again we have this offset value, and this offset value will be the fillet length. So we can create new parameter called fillet. It's again instance parameter, and let's group it under the graphics. Now if we look at our math schemes, we can see that these points are the start and the end of the fillet arc, and the offsets of these 2 points represent the fillet lengths needed for the calculations. So we need to add another point, set work plane, and add the point to the second reference line. Okay, now select the point, and now you can add the previously made fillet parameter to this offset property. Let's find the fillet. Okay, and now we have 2 fillet lengths needed for the calculation. Now we just have to do this operation 3 more times. And again, you can kind of skip this chapter to the next chapter, because I'm doing the same thing just 3 more times. Adding 2 points on 2 reference lines, hosting them by the intersection of the other reference line. Now add 2 fillet points. Okay, select point, set work plane, select the correct work plane. Okay, add the point, select the point, and add fillet parameter to the offset property. And now if it moves on the wrong direction, select the host point and check flipped constraint. Now select point, set work plane, select work plane on the point, add point, select the added point, and add fillet parameter to the offset property. And again, this point goes to the wrong direction, so we need to select the host point and flip it. Okay, great. Let's move on to the next corner, and we have to do exactly the same things. Add 2 points, select one of them, set host by intersection with the reference line, select another point, set host by intersection. Now zoom in for better view, select point, set work plane, and check the right work plane, add point, and add fillet parameter to the offset property. Okay, this point moves in the right direction. Now we need to add one more, set work plane. Okay, click and add the point. Now select the point, and add fillet parameter to the offset property. And this point moves to the wrong direction, so we need to again flip the hosting point. Okay, great. Now the last corner, Let's zoom in. And I'm going to add 2 points. 1, 2. And select close by intersection. 2. Okay, now zoom in for better view. And these points are too close together, so we need to move up the adaptive point. Okay. Select point, add it. Set work plane, add the point. Okay. Select the first point and add offset fillet parameter, and this also goes in the wrong direction. And we'll fix that later. Now select the second point, add fillet parameter, select the host point and make it flipped. Okay, cool. Now add a reference line between every 2 points you just created. That is the start and the end of the arc fillet. And we need to get the middle point between these 2 points. And it's best done with a reference line between these 2 points. We will add a point in the middle. So now let's double check that the fillet is working. Okay, fillet is working and the points are moving. Let's save the model. And let's check our schemes. Now, we are in what position we are? We need to get the middle point of the base of the arc. Okay, we are in kind of this position. We are trying to get the middle point for the arc. And now we have the fillet length. Okay. Okay, so now we'll add a point on those reference lines. Select point and add point to every reference line you just draw. One here, one on the next one on the next one, and one in the last one. Now select the point and add a normalized curve parameter of 0.5, so it's always in the middle. Select the other 3 points and add curve parameter of 0.5, so they are always in the middle of that reference line. Now we will add a reference line between the curve beginning and the end of the curve. One reference line and the second one. And one from the middle to the adaptive point. And we'll do that for every corner of this rhomboid. One in the middle and 2 on the sides. One in the side, one in the middle, and one in the other side. One in the side, one in the middle, and one reference line in the other side. Okay, cool. Now let's check that everything works as expected. Add fillet length and see that there is no errors anywhere. And save the model as always. Now the next step is to add a point where it's going to be the middle of the arc, the main point we're after with all the calculations. Select point and add it to the middle of the reference line. Now, if you look at our schemes, this is the point that we are calculating in the last step. This is the middle of the arc, the most important point to get the arc right. And we need to calculate this length 1e. So let's do that. Select the point, and instead of normalized curve parameter, we can choose segment length. So this length is going to be this dimension 1e. Let's say it's going to be 10 or 50 or whatever is the outcome of the calculation. So let's add 3 more points, and another one, and the last one. Select the point and set measurement type to segment length. Now we need to check that point is moving in the right direction. We can check that by entering a segment length value. If the point moves on the other direction, let's say 10 from the adaptive point, you can always set the measurement not from the beginning but from the end. Now let's draw the reference arc, the beginning, the end, and the middle. This is going to be our fillet arc. And if we select the middle point and change the segment length value, you can see that the reference arc is following the middle point. And this is the calculation that we're after. Okay, let's add 3 more reference arcs. Beginning, end, and the middle. Again, beginning, end, and the middle. Beginning, end, and the middle. Now, let's save the model and add 1e parameter to the offset property. Select the point, select add parameter, create new parameter, and call this 1e. This is going to be also an instance parameter, and let's group it under the graphics. Again, okay, click OK. Now let's go to the next point. This is going to be 2e. Let's add a parameter to the offset. New, call this 2e instance. Add it to the graphics group. Okay. Now the next one is going to be 3e. Let's add a new parameter called 3e as instance. Okay. Under the graphics. Okay. And the last one is going to be 4e. 4e instance parameter and under the graphics. Okay, cool. Now let's save the model and onto the calculations. Now let's add new parameters that we are going to use in our calculations. Set new. First one is going to be angle 1. It's going to be instance, dimension, and type of parameter is angle, and group it under the graphics. Okay, so next one, let's move it to the top. That's the first one we're going to calculate. So again, next one is going to be len. It's going to be also instance parameter and also under the graphics. Okay, now the next one, let's move this up. That's the second one we're going to calculate, and the next one is going to be 1r. That is also instance parameter and grouped under the graphics. Now we have all the parameters made. Let's move the 1r to the bottom. Okay, apply, and let's take a look at our schemes. So the first thing we need to calculate is the angle of the first corner. Let's take this expression, copy, and go to the parameters panel and paste it. Okay, and we have our first angle. Okay, now let's go back to schemes. The second expression. Okay, it's for len. copy that, go to the parameters and paste it under one length. Okay, now we have the one length. Now the one error. Okay, let's go back to the schemes and copy the one error expression, go back to the parameters panel and paste it under the one error. Okay, and the last one is 1e. Let's go back, copy the 1e and go back to the model parameters panel and paste it under 1e. And here we go. Let's hit apply. Okay, and as you can see, the 1e is calculated and we have a perfect corner fillet arc. We can see that it's tangent to those two lines, and that is exactly what we need. Okay, now we just have to do this 3 more times. Let's check the fillet, let everything works. And here you can see that if we change the fillet, the arc changes with it. And that is great. Now let's save the model and go to the second point. Second adaptive point. Now we need to zoom in. Okay. And okay, we need to calculate that point. Okay, now let's go back to the parameters panel and we need to add few more parameters. Press new instance and it's going to be 2ang angle for the second point. It's under type of the parameter is angle. Another one is going to be 2len and that's length. Type of the parameter under the graphics instance parameter. Okay, and next one is going to be 2er. That is also a length parameter and under the graphics. Okay, cool. Now let's order them. It's always good to order the parameters in the order that you're calculating them, so it's easy to understand later when you want something to change. Now let's zoom out a bit to see what sides are we using for this parameter. It's going to be L12 and L23. Okay, go back to the parameters panel, copy the first expression, paste it, and let's see, what do we have to change here? It's going to be L12, that stays the same. Now L14 is going to be L23. The diagonal is going to be L13D, and here L12 stays the same, and L14 changes to L23. Okay, that's great. We have our second angle. Now 2len. Let's copy the expression from the 1len and let's paste it and change 1ang to 2ang. Okay, next 1er. Let's copy that, paste, and 1len to 2len and 1ang to 2ang. And okay, and 2e. Let's copy that, paste, and 1er to 2er. 1er to 2er and 1len to 2len. Okay, cool. And voila, the second fillet is looking great. Now let's move on to the third fillet. Save the model. That's always important. And let's go to the third point. Now let's zoom a bit out so we can see on what parameters we're working on. Okay, now we can also duplicate the parameter. Let's duplicate that one and rename it to the 3ang. Okay, now select tooln, duplicate it, and rename it to 3len and 2r. Where is it? Okay, 2r, duplicate it and rename it to 3r. Okay, cool. Now we need to reorder them. That goes down. Okay, that goes down. And now we need to change the parameters that we're working on. L12 goes to L34 and L diagonal is going to be 24D, and here L12 is going to be L34. And when we hit apply, here you can see that when the calculation is done and you select that parameter, let's select that parameter, you can see that it kind of selects in the orange the parameters that we're working on that are in this expression. So we can now change the next one to 3ang, and the next one 2len to 3len, and next one 2ang to 3ang. Okay, and the last one, let's copy the expression from 2e to 3e. Let's change the names of the parameter and hit apply. Okay. Now let's move on to the next point. Select that. Okay, it's 3e and everything looks great. Now let's move to the last adaptive point for saved model. Okay, now let's open the parameters panel. And duplicate the previous parameters for the fourth point. Okay, let's duplicate 3ang and rename it to 4ang. Now let's duplicate 3len and rename it to 4len, and 3r, let's duplicate that one and rename it to 4r. Okay. Now let's order them in the right direction. And that goes down. And okay, now we need to zoom out a little bit to see what parameters are we using. L34 and L14. Okay, let's go back to the parameters panel and let's see. Now first for ang we are using L34 and L14, and diagonal is L13D, and these are L14. Okay, now this is going to be renamed to 4ang, and this is going to be renamed to 4len and 4ang. Okay, now for the 4e, let's copy that, paste, and let's rename it to 4r and 4r and 4len. Let's apply that and hit OK. Now That looks great. That is 4E and everything is looking very good. Okay, go back to parameters panel and let's check the fillet. Let's change the value to 250 and voila, everything changes accordingly and everything looks very nice. Okay, so now let's add a reference line here and we can start to add surfaces. To check that everything works, let's select those reference lines and click create form and then choose surface. Okay, now we have our first surface. Let's check that everything is working as expected. Let's move that point and everything seems to be connected. Okay, select these three reference lines, create form, select surface, and okay, let's move on to the next one. Select these three, create form, and select surface. Now let's create another reference line here and select that one, that reference line, this one, and that border, and create form. Select surface and let's move on to the next one. Let's add another reference line here. Now let's select that reference line, this border, that border, and the outer border. Create form, select surface, and let's move on to the next one. Now let's select these three reference lines, create form. Okay. Now let's move on to the next one. Let's add a reference line between these 2 points and select that, this border, the outer border, and this reference line. Create form, select surface. Okay, and the last one is this one. Let's add that side and the left side. Create form, select surface, and here we go. This is the top side of our 4-point adaptive family. Let's check that everything works as expected. We have no errors here. Let's change the fillet to 50. Okay, and voila, everything changes with it. Okay, let's change the offset to 50. Okay, cool, everything changes and everything works as expected. Let's align those back. And this one also. So it's easier to understand the shape of this whole family. Okay, so all the points are in the same work plane. Let's move this one a bit further. Okay, the next step is to add a depth to this family. Basically, we use the same principle as the top, but it's deeper down, and we can control the size of the depth and the size of the fillet separately. Now, how do we do that? First we need to dissolve this surface to the basic elements. Let's dissolve it and add a point here. Select point, set surface, and this time not the vertical but horizontal work plane. Select that, add point here, and now select the point, and when you add a offset value like minus 100, the point moves down. So this is going to be the depth of our model. Now let's dissolve the next surface and the next one and the last one. And now what we need to do is add a parameter to this offset property. Let's call that offset back, because that's the back offset. Okay, instance, and let's group it under the graphics. Okay. Now let's rename it to the depth. This is going to be the depth. Create new parameter, the depth, and it's going to be a type parameter because for all the panels the depth is going to be the same. Let's group it under the general and hit OK. And now we will add a back offset point. Let's select point and set work plane vertically parallel to the top. Okay, add point, and now when you add like 100 value, this is going to be the back offset. Now select point and change this to the back offset, and yeah, we have to change the value that it's not negative, it's positive. Let's say 100. Okay, and now it's moving in the right direction. Okay, now we need to add 2 more points. Let's select the vertical work plane, add point, and the use for this point is going to be exactly the same as above. So we can select the point, and for the offset property we can add the same parameter as above, because this point is going to also extend beyond the border of our rhomboid, and we can use the same length as above. Add another point also to the vertical work plane, hit OK, select that point, and we can also reuse the same parameter as above. So this point extends on the opposite direction, also outside of the rhomboid, and we can connect these 2 points and get the offset line for the bottom of this model. Now we need to do this again 3 more times. Let's select that. Now let's set the horizontal work plane for this point, add a point here, and add a depth parameter to the offset property. Where's the depth? Okay, and now this moves up because the direction of the axes are wrong, so we need to create another parameter. Let's go to parameter panel. Let's change depth to the positive value. Okay, now this moves in the right direction, but we need to change this one. So what we're going to do is create new parameter called depth negative. Create new parameter, or duplicate that one and create depth negative, and is going to be exactly the same as the depth, but the just negative value. So write minus and depth. Okay, so this is going to be a negative value, and we can add that parameter to this point. So this is going to be depth positive and this is going to be depth negative. Select that and set to depth negative. Okay, now this works as supposed to. Now let's add another point exactly like this one to the next line. Okay, let's set this to the vertical work plane. Select add point, select the point and add back offset back parameter to that offset property. Okay, great. Now 2 more points for the extensions. Select that, add point. Okay, we can reuse the parameter again. Let's scroll down to L23 offset extension. Okay, now add another point, set work plane, draw a point, select the point, and this is going to be L23 negative. Okay, that's moving to opposite direction. That's great. And add a reference line to those 2 points. Let's connect them. Okay, great. 2 more reference lines to go. Okay, let's move on to the next one. Everything looks good. Okay. So now, again, select point, set reference plane, horizontal, add point. Okay, select the point and add offset parameter as depth negative. Okay, great. This moves down. Another point. Select work plane, vertical. Miss that. Okay. Add point. Okay. Select the point and add a offset back parameter. Okay, great. Now 2 more points. Okay, set work plane, select that one, add. Okay, great. Select the point, offset again. We can reuse L34 offset extension and the point moves in the right direction. Again, another point. Okay, and this is going to be L34 negative extension. Select offset L34 negative extension. Okay, great. Now we can add the next reference line. Let's connect these 2 points. Okay, great. Now we need to add the last back offset line. Select point, set reference to horizontal, add point. Okay. Now select the point and add a depth parameter. Okay, where is it? Depth, okay. Depth negative, okay. So now we need to add another point. Vertical work plane, okay. Select the point, okay. Set to offset back, okay. That moves in the right direction, everything is cool. Now select set point, set work plane, vertical, okay, add point, okay. Select that point and we can again reuse L14 offset extension. Okay, great. And we need to add 1 more point, set and add point. Okay, and we are going to reuse L14 negative. Okay. Now add a reference line between these 2 points. Okay, great. Now let's open the parameters panel and check that everything works as expected. Let's change the back offset to 200. Okay. And here we go. The offset is changing accordingly. That is great. Now we need to add a fillets. Let's save the model, and we need to do exactly the same as above. Now let's move this adaptive point a bit up so we can see these 2 points on the intersection a little bit better, because if they're in the same plane we cannot see them very well. Okay, add 2 points here and here. Select the point, host by intersection, and select the other reference line. Select that point, and again host by intersection, and select the other reference line. And when you zoom in, you can see there's 2 points. Cannot see them very well, so we need to move this point a bit down so there's a bit bigger difference. Okay, great. Now here you can see there's 2 points, one above another, but they're on the intersections of these 2 reference lines. And that is exactly what we need. Okay, let's add 2 more points. Let's set work plane, add point, okay. Set work plane, select vertical, okay. And select that point, and we are going to call this, let's check that fillet, and we are going to call this a fillet back. It's going to be an instance parameter, and okay, this is going to be fillet back. And let's change this to, let's say 100, and let's group this under the graphics also. Okay. Now we need to change this to fillet back. Select the point. Okay. Now first fillet for the back is done. Now let's add a reference line between these 2 points, same as above. Enable 3D snapping and add 1, 2. Okay, great. Okay, everything looks great. Now we need to add 1 more point to this corner, and this is going to be the depth for this adaptive point. So select new point, set work plane to horizontal, and add point here. Now select the point and add the same depth parameter to this point. Okay, depth. Okay, cool. No, we need to set a depth negative for this one. Okay, now it moves down. And now we need to set another point to make the center line. Okay, add point to this reference line, select it, and as above, add 0.5, so it's always in the middle. Now connect these 2 points as we done above, and add a point that is going to be for the arc's center, and set measurement type to segment length. And you can see that if we write 10, it jumps to the wrong end of the reference line, so we need to set measure from end. And then when we add 10, it goes to the end of the reference line, exactly where we need it. So we add a new parameter to this property called 1e back. Now let's call it underscore 1e, so we can better see all the backside parameters. And let's group this also to the graphics. Okay, great. Now let's go to the parameters panel, and we need to duplicate more parameters for this back fillet to be calculated. Let's duplicate the one length. Okay, let's call this underscore 1 len. Now let's move this to the side so we can see better. Okay, Now let's change this to fillet back. This to fillet back. And this also to fillet back. The angle is the same, so we can use the same angle as above. And now we have one length. Okay, great. Now duplicate one error and rename it to underscore one error. Okay, cool. And now let's move this down, and we can rename this to underscore one L len. One angle stays the same. Now we need to duplicate the one E. Let's copy the expression and rename it to one error underscore one len. Okay, great. Now let's move this down. Okay. And now we can add our reference arc. Let's add beginning, end, and the middle of the arc. Okay, great. Let's check that this is underscore 1e, and it is underscore 1e. And the fillet looks great. So next we need to do this again 3 more times. Let's add reference lines here and here. This is for the surfaces. So we can select these 4 reference lines and add a surface here. Create form, and here you go. Here is the surface. It looks kind of funky, but when we straighten out those adaptive points, then it will look alright. So now, what do we do next? Let's add a fillet for the next point. Same as before. Let's add 2 points here and here. Select the point, host by intersection. Select point, host by intersection. And make 2 points for fillet length. Okay, add 1 point here. Set work plane, add 1 point there. Okay. Now select the point and add fillet back property to this parameter to this property. Okay, as this moves in the wrong direction, we need to flip this and select that point, and again add a parameter to this property, fillet and fillet back. Okay, this also moves in the wrong direction, so we need to select the host point and flip it. Great. Now let's connect these 2 points. Now add the center point here. Select the point. Normal score parameter is going to be 0.5 again in the middle. And now we need to add depth to this adaptive point. Select the work plane, horizontal, and add point. Select the point and add a depth parameter to this property. This is going to be a depth negative. Okay, now add a reference line between these 2 points and add a point for 1e, no, not 1e, but 2e. Select the point, change this to segment length, and change this to the measure from end. Okay, great. Now add a curve reference line here, and now we need to add a 2 underscore 2e underscore 2e parameter to this property. It's also instance and group under graphics. Okay, now we are done with this corner. Now let's move on to the next corner. Zoom in and save the model. That is always important. Now add 2 points to these reference lines. Select the first point, host by intersection. Select the second point and host by intersection. Now add 2 fillet points. Select work plane, add point. Okay, select work plane, add point. And select the point and add fillet back parameter. Okay. Select point and add fillet back parameter. Okay. Now select point, set work plane and add a point to the adaptive point. Select the point and this is going to be a depth negative parameter. Okay. Now add a reference line between the arc start and arc end. Add a point to the reference line and set segment normalize curve parameter to 0.5 so it's always in the middle. Add a reference line between these two. Okay. And now add 0.4 underscore 3e. Let's change this to segment length and this to end. And now select the point and add parameter. We need to create new parameter called underscore 3e and to be instance and grouped under graphics. Okay. And we can also add a reference arc to this corner, beginning, end, and middle. Now, the last corner, we need to do exactly the same things. Okay, add 2 points. Select the first one, host by intersection. Okay, select the second one, host by intersection. Let's zoom in a little bit and so we can see better. Okay, add points, set work plane. We need to see exactly, is this the right work plane? So okay, let's set this one. Okay, add point. And for that point we need to kind of rotate the view. We need to be sure that we select the right work plane. Okay, I think that is the right one. Okay, add point. Select. Okay, let's select that point. And add offset is going to be fillet back. Okay, great. Now we need to flip this. Okay, now select that point and also add a fillet back parameter. Okay, and also we need to flip that point. Okay, great. Now we need to add a depth point for the last adaptive point. Select work plane, add point, select point, and add a depth negative parameter. Okay, great. Add a reference line between the arcs beginning and end. Okay, now add a center point. Okay, select the point. Normalized curve parameter is 0.5. It's always in the center. And add a reference line between these 2 points. And now add a point for underscore 4e. Let's select this and set segment length and end. Okay, great. Now we can add a reference arc for the last adaptive point corner. Okay, great. Now let's add new parameter called underscore 4e. It's under the graphics and it's instance parameter. Okay, okay, okay. Now we can zoom out a bit and save the model again. And we're almost finished. Now we need to add few more parameters for the calculations of the fillet. So we can duplicate this one, and one error is going to be underscore 2 error. Okay, great. Now let's duplicate one len. There's going to be underscore 2 len. And let's duplicate. And let's change it to ang. Okay. And let's move the parameter down. Okay, let's move that down and change this to 2 len and to 2 ang. Okay, great. Now let's move this down. And let's copy 1e expression to 2e. Let's change this to underscore 2r, 2r, and 2 len. Okay, great. Now let's apply. Okay, and let's see. The 2e is working as expected. Okay, great. Now let's go back to the parameters panel and let's duplicate a few more parameters. Like 2 len is going to be 3 len. Okay. Now let's change this to 3 ang. Angle is the same as above. Now let's duplicate 2r. Is going to be 3r. Okay. And let's change the expression to 3 ang and 3 len. Okay. And now copy the expression from underscore 2e to underscore 3e and change the expression to 3r and 3 len. Okay. Okay. Now let's reorder them. And now the ordering is so slow. Okay, let's apply, hit OK, and save the model because we don't want to lose this much of our work. Okay, back to parameters panel. Now the last point, the last fillet. Okay, let's duplicate 3 len and rename it to 4 len. Okay, and let's change this to 4 ang. Okay, now scroll down a bit and let's duplicate 3r This is going to be 4_4R. Okay. 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 Let's change this to _4len and 4ang. Okay. Now we need to copy the expression from 3e to 4e. Let's select and paste. Change this to 4r and 4len. Okay, now we have all of the fillets calculated, and all we need to do is reorder them. Let's move this down. And let's move that down also. Okay. Now we are almost done. Everything looks great, and the fillets are working. Now we need to connect these two points for the surfaces. Okay, select that and that. At that point, connect that point. Okay, great. Now same here. Reference line at point here and here, and another reference line here and here. Now add another reference line here down below, and another one here. This is just for surface boundaries. Another reference line here for the boundary, and another reference line here. Okay, great. Now let's add another reference line here and another one here, also for the boundaries for the surfaces. Let's select those. 1, 2, 3, 4. Create form, and here we have this surface. Now select this reference line, this one, that one. Select, these are the boundaries. Select that reference line, create form, and here you can see that we have a problem. We don't have selection between the surface and extrusion. So don't get discouraged. Just select the same reference lines, just in different order, and create form again. And when you do that, you can see that there is a menu down below. You can select the surface and create the surface that you want. Again, select for borders and create form. And let's move on to the next one. This one, select for borders, 2, 3, 4, create form. And let's move on to the next one. Select for borders and create form. Okay, select surface. And if you don't succeed, just select those reference lines in different order and try again, because this is some kind of bug, and you just have to select it a few times just to see the menu. Okay, select here again, and I got the same bug here, so I needed to select those lines a few times before I could see the menu. Create form and select. Okay, great. And now one more. Okay, select that, and another one, and create form. And here you can see that the menu is like it's popping out of the window. So basically, I think this is what's happening in previous times. The menu just pops up out of the window and we cannot see it. So we need to try again. So select again these borders and create another surface. Select the surface and we have our last surface. Select 1, 2, 3, 4 borders, 4 reference lines, create form, and we have our last surface. And this is it. This is how you create a very complex adaptive panel. So let's check that everything works as expected. So the form must follow these 4 points. Let's move that one. No errors. Okay, that's great. Let's align this back. We have a warning about line slightly off axis, but that's nothing. Okay, let's align this so we can better see the form. Align this. And this is basically the form that we are going to use. Let's move this point a bit up. And as you can see, everything follows this point. So this model is fully parametric and adaptive. So let's check the parameters. Let's check the offset parameter. Let's change this to, let's say, 300. Apply. You can see that everything is recalculated and we have a great back offset. Now let's change another one. Let's say fillet back is going to be 200. Okay. Line slightly out of axis, that's nothing. And we have our fillet back. Now let's change the depth. Let's say to 200. And everything works as expected. And if you followed through the video, I hope you learned much about adaptive families. And in the next video, I will show you how to use those parameters with the help of Dynamo and to use this family in divided surface. And if you have any questions, feel free to leave them in the comment section or in the Facebook group. And thank you for watching. Save the model. Have a great day and see you in the next video.